Okay, so in this video, we're going to take a look at inverse functions. Now, if we think about a function, right, okay, what it does is it takes an x and it maps it over to a y, right? So if we call that function f, okay, maybe it looks a little like this. Now, what an inverse function does is it takes those values, okay, that were outputs, like the y's, and it maps them back. Okay, so we denote it with an f of a little -1 there, okay, and that's the idea. It takes what the range was from the original function and maps it back to that original domain, okay? So the domain of an inverse is the range of the original function. Now, one of the interesting properties of that, okay, is geometric. So for example, supposing you knew that f had the coordinate point 1, 3 in it, okay, that was in f. Well, in f minus 1, we would have 3, 1 in it, right? Of course, because the original function mapped to 1 to being a 3, so the inverse function maps the 3 into the 1. And so this creates this interesting property. If you think about plotting this graphically, right, okay, 1, 3 and 3, 1, okay, are going to be a reflection in the line y equals x. And it would work for any point. If I had the point 2, 7, well, the inverse function would have 7, 2 in it, right? Okay, it does the opposite. 2, 7's up there somewhere. Okay, 7, 2 is over there. It's going to keep having this property. So that's worth considering as well. And of course, what an inverse is doing algebraically is it's undoing the algebra that happened to the original function. And luckily, we know some inverse operations already. We know that addition and subtraction are inverse. We know multiplication and division are inverse too. So we're going to use all these properties to help us. Let's jump in and have a look at a quick example or two. So we're going to start off with f of x. The original function is a half x minus 1. Let's see the process algebraically of finding that inverse function. Now, we're going to start off by writing if you like, a place value holder. And I'll call it a y, but it could be any symbol at all, right? We're going to write this function equal to y. And that's going to give us something to operate on. So let's undo the steps that were taken to get this f of x. So I'll start by adding 1 to both sides to undo that -1. So that would give me y plus 1 equals a half x. Now I'm going to multiply both sides by 2, and that's going to get rid of that multiplying by a half there, look. So if I did that, I'll write it in expanded form. 2y plus 2 is equal to x. And what I've done is I have created a function here acting on y that is the opposite of what was acting on x earlier, okay? We call this variable interchange. Now, we're almost finished. The last thing to consider is what we were asked for was f minus 1 of x. So the original inverse, but acting on an x. We're always acting on the thing in that bracket. So rather than writing 2y plus 2, I better write x rather than y because we're acting on x. It's whatever's in that bracket. So we're going to write 2x plus 2. And there we go. We've done our inverse function. Now, I didn't have to use y. I mean, I could have used any symbol at all. It was just something to operate on to help us to undo those steps, right? Okay. But whatever you do, you must rewrite it at the end in terms of x because we were asked for that function, okay, acting on an x. Right. Now then, let's have a look at part B. Let's sketch f of x and f minus 1 of x. And the line y equals x on the same axes. Now, forgive me, I'm going to keep this video nice and short, and I'm going to cheat. Here's the answer. Let's take a little look at this, right? Okay, we've got that original function, y equals a half x minus 1, look there, going through -1, having a gradient of a half. We've got the other function, y equals 2x plus 2. Look, the thing we found here, having a steepness of 2, and intersecting with that y-axis at 2 as well. And of course, you can see the reflection. It is a full reflection in the line y equals x. Okay, let's carry on. Let's take a look at a different example. Now, just to really nail home this point, let's not use y when we try and find f minus 1 of x. Let's use any symbol, right? I'm going to use a heart symbol, right? So step number 1, set something equal to 3 minus 2x plus, over 4, the original function, and then start to undo the things that are happening to x in that original f of x. So clearly I've got to make x the subject. I'm going to start by multiplying both sides by 4, right? So 4 lots of that heart symbol equals 3 minus 2x. Okay, now I need to take away 3 from both sides. So 4 heart symbol minus 3 equals minus 2x. Now I'm going to divide both sides by minus 2. 4 lots of that heart symbol minus 3, all divided by minus 2 is equal to x. Now, perhaps it would be better for me to multiply top and bottom there by minus 1. I'm not going to do that because I want to keep the scope of this video all about the inverse function, so I'm going to leave it where it is. Final thing to do is just to make sure we write it, okay, with x as the variable we're acting on. So final answer for part A, f minus 1 of x is 4x minus 3 over minus 2. Right, we're finished. Now, I'm not going to sketch this one, okay? We're going to move on to the next example because I want to keep this video short, but if we were to plot these, which is the feature and subject of other videos, they would reflect along the line y equals x. Right, now let's just go for a super challenging one where the subject appears twice. If we have something like this, it's the same process, but it's a little tricky. Let me just show you how to do this. So step 1, we set that equal to something. I'll use y this time again. So y equals 2x plus 1 over x plus 3. Okay, now we're going to attempt to make x the subject. So we'll start off by multiplying both sides by x plus 3. So that's y times x plus 3 equals 2x plus 1. Now we're going to expand that bracket on the left. xy plus 3y equals 2x plus 1. At this point, we want to make x the subject. We're going to bring the x's to the same side, and then we're going to clear out anything that isn't an x from that side. So I'll choose to bring those x's to the right-hand side. So if I am doing that, I'm going to take a xy from both sides, and I'm going to also at the same time take a 1 from both sides. So that's going to leave me with 3y minus 1 equals 2x minus xy. Now remember, the point of this is to make x the subject. X appears twice at the moment, so the point of doing all that was then I can factorize. So if I keep the left-hand side the same, let's take a factor of x out, and what that's doing is it's just making that x appear once, which is what we need to happen in order to make x the subject. Last thing to do is to divide both sides by 2 minus y, so 3y minus 1 all over 2 minus y is equal to x. Now, again, don't forget we're asked for f minus 1 of x, which means we're acting on x, so our final answer should be written like this: 3x minus 1 over 2 minus x. Okay, so hopefully that made a little bit of sense there, okay, and you could follow those steps and even have a go at some of those really challenging examples like